So the session now is continued by Mrs. Sonam Bandurge, Assistant Professor of CAC Department AITM. So ma'am has done MTech in Digital Communication and Networking from GIT and pursuing PhD, teaching experience about 8 years. Sonam ma'am is PhD researcher working on the project titled Generative and Explainable AI Model for Augmented Data and Predicting the Severity of the chronic kidney disease using machine learning. Area of expertise in machine learning and explainable AI and generative AI. So I welcome Professor Sonam ma'am. So I request ma'am to continue the session.
Good afternoon, everyone. Is my voice audible?
It's audible, ma'am.
Yes. Yes. First and foremost, I would like to thank the management of AITM, Principal Sir, and Dhanashree ma'am for providing me this opportunity to present this webinar. Thank you, participants, for joining today's webinar on a topic that's not just timely but transformative. Role of generative AI in intelligent transportation system. I will take you through some groundbreaking applications, real-world case studies, and future of transportation powered by generative AI. Imagine a world where traffic lights adjust themselves in real time. Vehicles avoid collisions before they happen, and cities can simulate their traffic conditions months in advance. All this is powered by artificial intelligence. That's the future we are heading towards, and it's happening faster than many of us think. Before we connect AI to transportation, let's quickly understand what generative AI means. Generative AI refers to a class of artificial intelligence model that can create new content from the existing content. The content can be text, images, sounds, or even video. It doesn't just analyze data like your traditional AI, but it also generates new data from the existing one. Think of it like this, like while traditional AI might help a traffic system analyze congestion patterns, your generative AI can simulate what would happen if we added a new flyover or change the traffic light timings across the city. It can all this is possible through generative AI. It can generate realistic future scenarios based on the existing data. Several powerful models are behind the rapid progress in generative AI. Let's take a quick look on the leading ones. GANs, that is Generative Adversarial Network. Here, they use two neural networks which are competing with each other. One generates the content and the other evaluates it. This leads us to very realistic outputs like human faces or traffic patterns. The next is variational autoencoders, which are called as VAEs. These models learn to compress and then reconstruct data. They are great for generating variations of inputs, like simulating slight changes in weather or traffic over time. Next is diffusion models. Diffusion models, they usually generate images by starting with noise and refining it step by step. They are excellent for creating highly detailed visuals. The last is transformers. These are the powerful language models like your ChatGPT. They understand and generate human-like text and are now adapted to generate your code, images, and even simulate decisions making in traffic systems. Each of these models contribute uniquely to make generative AI smarter and generative AI systems smarter and more versatile in real world applications. So generative AI helps to solve one of the biggest problem what we face in AI, that is not having enough good quality data. So this is possible using data augmentation. That is, using data augmentation in generative AI, we can slightly modify the existing data to create more realistic, to create more training data. So the examples here would be like if I have to rotate or crop or add noise to the traffic camera images to train better detection model. So that is what is done in data augmentation. Then synthetic data, this is the data that is generated by AI, which looks and behaves like real data. Example here would be if you're creating a artificial traffic flow data for rare scenarios, like if you are creating some accidents or road closures. So the next is scenario generation. This here also the generative AI generates complex, realistic situation that may be hard to capture in real life. Example, simulating how self-driving cars would behave in foggy weathers or during a signal failure. So these techniques allow us to train smarter systems faster, especially in safety critical areas like transport, where real world data is limited, biased, and costly. So now that we have understood what generative AI is, let's look at what it fits in, especially in intelligent transportation system. Intelligent transportation system refers to the use of advanced technologies like AI, sensors, and communication systems to make transportation networks smarter and safer and also more efficient. So the components here, the ITS for traffic management systems, which controls signals, monitors flow, and responds to real-time events. Next is ITS for autonomous vehicles, which use AI to navigate without human drivers. And the next is public transport ITS for public transit systems that are enhanced with predictive scheduling and route optimization. So the goals of yes, the goals of ITS are you improve the safety by reducing the human error and reduce the congestion by predicting the traffic pattern and reroute your real-time data and enhance the sustainability by supporting eco-friendly transit and reducing idle time to make smart decisions. So as I said, your ITS requires your ITS requires more yes, your ITS requires, it is totally dependent on heavy data, that is from sensors and cameras to track the traffic and weather, and from GPS and connected vehicles to provide live locations and performance data. All of this creates a dynamic system that respond real world conditions and make generative AI further enhanced. So let's now look how globally ITS is being adopted. Here are few examples. First is adaptive traffic signals. So here the timings of the traffic flow are changed automatically. And the next is a smart parking solution, where it guides the drivers for the available empty spots to park. And the next is FASTag, that is your electronic toll collection system, which uses RFID to enable cashless and uh, contactless toll payments on national highways. So usually this electronic toll collection system, it reduces your traffic congestion at toll plazas, and also it helps you to track the vehicle movements in real time. The next is AI-powered surveillance, which is being used everywhere nowadays, uh, 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 where there are cameras and sensors across key junctions. These systems detect traffic violation like red light jumping, overspeeding, and wrong lane driving automatically. All this is being done using your AI-powered surveillance, where nowadays you can see if there are any violators, they receive this e-challenge like SMS with photo evidence. All this is possible without the human intervention. So you have some mobile apps also like Yatri and Chalo. These ITS apps, they are used in cities like Bangalore and Mumbai, which provide real-time bus tracking. uh, it also gives you the crowd information. It schedules the prediction for public transit, and so on. These developments show how ITS supported by generative AI and data is transforming not just global cities but Indian infrastructure too, making it smarter, faster, and safer. So the current applications of generative AI in transportation are, there are five major areas where the technology is making an impact. The first one is predictive traffic management. Here, imagine a city like China, Beijing, that is China. Here, generative AI is at the heart of the sophisticated traffic control system that monitors and optimizes traffic flow in real time, which reduces the congestion and travel time of people. So another example is the traffic signals. These signals are not just automated but intelligent. They analyze traffic patterns and adjust their timings dynamically. The next is autonomous vehicles and ADAS, which is nothing but advanced driver assistance system. In this space, generative AI is a game changer, where you have this Tesla's autopilot system. This is a prime example which uses AI not just for basic driving, but for advanced features like line keeping, obstacle detection, and even full self-driving capabilities. You have another example, that is Waymo, which is Google's autonomous car division, which goes a step further by using generative AI to simulate complex driving scenarios. These simulations help in autonomous vehicles to respond to rare critical condition and make it safer. So the next one is road safety and hazard detection. Now, there is a app which is used by Israel, that is Mobilia, which uses generative AI to identify some hazards, that is potential hazard, pedestrian hazards, traffic signs. All these are being possible in real time. This helps the drivers react faster and avoid accidents. So Singapore also uses a model that is accident prediction. Here, generative AI analyzes traffic data and predicts where accidents are most likely to occur, enabling proactive safety measures. The next is smart navigations and route planning. This is another area where generative AI shines, that is Google Maps, which is being used everywhere to predict the traffic conditions, also to recommend the fastest routes, and even provide some real-time traffic updates. This technology is not limited to navigation apps. You have some ride-sharing apps also, like Uber and Lyft, which use generative AI to optimize driver routes and match drivers with passengers um, more efficiently. The last is public transportation optimization. Here, generative AI is streamlining the operations. There's the London Underground in the UK uses it for demand prediction, that is, analyzing passengers' data to optimize the train schedules. In China, there are some smart buses which use AI to automatically adjust routes and timings based on real-time traffic conditions, ensuring that passengers reach their destination faster. As you see, generative AI is already driving a force faster, driving force behind smarter, safer, and more efficient transportation system worldwide. And this is just the beginning. Now let's explore how generative AI is helping optimize traffic system in modern cities. Uh, 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 Generative AI can create realistic traffic scenarios, as I already explained prior, using some historical and live data. This helps urban planners test different infrastructure changes, like uh, adding a new flyover or a traffic signal before implementing them in real life. So next is flow improvement. By analyzing real time data, generating generative AI can predict traffic congestion and uh, dynamically suggest alternative routes. It even helps optimize signal timings to maintain a smoother vehicle flow, especially during the peak hours. Uh, so let's dive into our first case study, how generative AI is transforming traffic optimization. Our first case study is about how Singapore has used the AI to revolutionize its transportation system. I will just have a look. We are going to watch that video.
One of the biggest challenges many cities across the world face today as a result of rapid globalization and industrialization. Traffic congestion in an economy leads to increased costs, reduced productivity, environmental impacts, decreased quality of life, and strains on infrastructure, affecting businesses, individuals, and the overall economy. Addressing congestion is crucial for an economy to tackle these issues. But there is one country that has mastered the art of traffic management: Singapore. And in this video, we are going to look at how Singapore, a small island nation, managed to become a global leader in traffic management. With a population of over 5.6 million people and limited land area, Singapore faced significant challenges in dealing with traffic congestion. However, through innovative policies and smart transportation solutions, Singapore successfully transformed its traffic management system. Let's dive in and discover the secrets behind Singapore's success. The ERP system. The ERP system in Singapore refers to the Electronic Road Pricing System. It is a road tolling system implemented by the Land Transport Authority, LTA, in 1998 to manage and control traffic congestion in the city. The ERP system uses gantries installed at various locations across the island, equipped with electronic sensors and cameras. Vehicles passing through these gantries are charged a fee based on the time of day, location, and level of congestion. The goal of the ERP system is to encourage motorists to adjust their travel plans, choose alternative routes, or use public transportation during peak hours, ultimately reducing traffic congestion on the roads. Before the ERP system was introduced, the average speed of traffic in the central business district during peak hours was just 15 kilometers per hour. However, after the ERP system was introduced, the average speed of traffic increased to 25 kilometers per hour. This is a significant improvement, and it shows how effective the ERP system has been in reducing traffic congestion. Efficient road infrastructure and urban planning. Singapore's urban planning plays a crucial role in managing traffic. Planners carefully consider factors such as traffic flow patterns, population density, and land utilization. This strategic approach ensures that road networks are optimized for smooth traffic flow and connectivity. The city's continuous infrastructure development involves expanding existing road networks and constructing new infrastructure to accommodate the growing population and address traffic needs. Integrated public transportation. The Mass Rapid Transit (MRT) system serves as the backbone of Singapore's public transportation network. With an extensive network covering a significant portion of the island, the MRT connects various residential and commercial areas, making commuting efficient and convenient. Complementing the MRT system is a comprehensive bus network that reaches areas not covered by the train system. The availability of taxis and ride-hailing services further enhances the range of transportation options, providing flexibility for commuters. Thank you for watching this video.
I hope you found the video insightful. This case study is a great example of how technology can transform urban transportation, making it smarter and more efficient. So now let's dive into how generative AI is accelerating the development of autonomous vehicles. This is the one of the most exciting areas of intelligent transportation system. Uh, Initially, here, generative AI creates the synthetic data, uh, uh, the data that is nothing but your simulating different road conditions, weather scenarios, or maybe the traffic situations. This training data is used to teach vehicle systems how to recognize objects, pedestrians, or road signs without risking the real world accidents. So the next is a scenario simulation, which enables autonomous vehicles to experience rare and uh, dangerous scenarios, like a child running onto the road, or an unexpected lane closure. This improves the vehicle's decision-making capabilities in complex environments. The next is realistic sensor data. Now, generative AI mimics, or it uses the camera inputs. Instead of capturing millions of real-world frames, developers can train using high-quality AI-generated sensor outputs, which can save time and cost. Moving on, let's now explore our second case study, how generative AI is transforming in autonomous vehicle development. Uh, First, uh, let me just show you the video. Our first example here for autonomous vehicle is a Waymo vehicle, which is autonomous vehicle, which is used for public transport in San Francisco, Los Angeles, and Texas. So,
Welcome to the wonder of Waymo One, the world's first fully autonomous ride-hailing service. Now that you've got the app downloaded, you're ready to ride. To hail your Waymo car, just tell us where you want to go, and we'll automatically select the safest spot to pick you up and drop you off. Once you hail, you can follow along to see how far away your Waymo car is, and you can also check your estimated time of arrival to your destination. This may be updated along the way as we look out for things like traffic. You can edit your pickup and drop-off spots by adjusting the pin. The blue and green lines show you where the Waymo driver can safely pull over. You can add up to 4 stops along the way. Just be aware that the exact pullover spots may change due to current road conditions. Once it arrives, you can hop in and take off in a car that drives itself. It really is that easy.
So that is a perfect example of how AI is being used or it is being accelerated for the development of autonomous vehicles. Let's now look at the key benefits of generative AI in intelligent transportation system. The first is a cost reduction. By generating synthetic data, we significantly, obviously, we reduce the cost of collecting real world data. This makes the AI model to train faster and more affordable. Next is safety enhancement. Generative AI helps simulate dangerous and rare driving situations, which can enable safer and validation of autonomous vehicles. This actually helps in real-time scenarios, like what exactly happens before vehicles hit the road. The next is traffic optimization. It supports better traffic flow by predicting the congestion and traffic patterns, by helping the city planners make the smarter decisions while the construction of the roads. Next is sustainability. AI-powered systems lead to fewer idling cars with less fuel and usage, and this makes the transportation more eco-friendly and efficient. Overall, you can say that generative AI helps us build faster, safer, and you can say greener transportation system, benefiting both the cities and the citizens. There are a few challenges and limitations which we face while using AI. Some of them are that is data bias. First of all, the systems, AI systems are only as good as they are good only when they have been trained well. If the data is biased, the data that we use to train the model is biased, the outcomes can be unfair, leading to misinformation. So you have to make sure that when you are using the data, that it should be fair, and generated content is not much complex. The next is the generated next is accuracy. Accuracy, AI generated data, or you can say the predictions must be accurate and reliable. However, maintaining this standard is quite challenging, especially in applications like autonomous driving, where errors can have some serious consequences. Next is computational needs. AI models require massive computing resources for training and deployment. This can be a barrier, especially for smaller organizations who have limited access to high-end hardware. The last is ethical concerns. The use of AI must be aligned with ethical guidelines and regulations. Privacy and transparency are the key factors that must be maintained to ensure trust in AI systems. So, AI offers vast potential. We must be aware of these challenges and work to address them. Only then we can have full benefits responsibly. As the technology rapidly evolves, it is transforming how we plan, operate, and experience transportation system. Here are some four key areas that tell the future trends and opportunities powered by AI. First, let's talk about personalization. AI will enable highly customized transportation experiences, uh, from personalized route suggestions to adaptive pricing and user-specific vehicle preferences. AI ensures that transportation becomes more user-friendly. This can lead to enhanced user satisfaction and more efficient mobility solutions. Next, we have 5G and edge computing. With the rise of high-speed networks, we can unlock real-time AI application. Imagine a network of smart traffic lights adjusting in real time based on real conditions. Um, or autonomous vehicle sharing data instantly to avoid collision. So the next is collaborative AI. In the future, transportation will rely on multi-agent systems where different AI models work together. Uh, Autonomous vehicles communicating with each other. They need to coordinate their movements and even work with the traffic management systems. Um, the next is model innovation. The development of specified AI models for transportation must be crucial. These models will be designed to understand complex traffic patterns uh, and even predict the maintenance needs for the infrastructure. So, uh, the future of transportation will be driven by AI powered personalization, speed and connectivity of 5G, collaborative artificial intelligence between systems, and continuous model innovation. So these trends are set to reshape how we move, make transportation smarter, safer, and more efficient. As we come to the end of the session, uh, I would say that generative AI is reshaping transportation to be more safer, more efficient, and more sustainable. Uh, from optimizing traffic management uh, and enhancing autonomous vehicles, the development of smart systems, AI is revolutionizing the way we move. Uh, but this is just the beginning. The future of transportation will be driven by continuous research, innovation, and collaboration. And we are all part of this journey. Thank you all for your time and attention. I am now open for any questions you may have.
Thank you, ma'am. Thank you for your wonderful session. Can I ask a question, ma'am?
Yes, yes.
Can autonomous vehicles effectively navigate rural roads with poor infrastructure in India?
No, because uh, there are still too much of development which has to be done in rural areas. There are poor road condition, lack of traffic signs, or there might be some unpredictable obstacles coming and all. So yes, you are going to face significant challenges when navigating rural roads.
Okay. Thank you, ma'am. Thank you so much. Thank you for joining us today.
Thank you. Thank you.